guys and girls, a hopefully quite quick little video just on identifying geometric sequences, understanding what they are, the terminology that goes along with them, and like continuing them, that kind of thing. So, geometric sequences are ones where you don't add or subtract to get from term to term, but you multiply or divide. So, things doubling every time or halving every time, multiplying by 10, that kind of thing. They are geometric sequences. So all you're looking for when you're identifying them is if you start with your multiplication here, so if I go with the first one, that is a times 4. Is that times 4? Yes. Is that times 4? Yes. Therefore, that is a geometric sequence. Look at the next one. So that is divide by 3. So 27 divided by 3 is 9. 9 divided by 3 is 3. Yes, that is a geometric sequence. Next one, that would be divided by 6. Sorry, times by 6. But then the next one would have to be 36 for it to work. So that one is not. That one's actually just adding 5 every time, which is an arithmetic sequence, not geometric. Looking at the next one, to get from 1 to 10, you times by 10. And then that times, yeah, that works, and that one works, yes. Okay, 9 to 99 is times by 11, so 999 from 99 is that times by 11. If you take 99 and times it by 11, 1 to 9 is 9, 1 9 is 9. 9 again, so no, it's not going to be. So if I add these up, I'm going to get 1089. So this is not a geometric sequence. We look at the other side. So this one has been multiplied by 5. That's multiplied by 5. That's multiplied by 5. Yes. This one, double. Why my pen's gone small. Double. No, that one doesn't work. So that one is not. This one's been, you can either say multiplied by 0.1 or divided by 10. I'm going to stick with divided by 10. And each time I divide by 10, yes I am, so tick. Next one, there to there is times by 4. That's times by 4, that times by 4. Yes, they're all times by 4, so it is geometric. And the last one, so that would be 25 over 4 is 6.25. So times 6.25. So if I take 25 and multiply it by 6.25, am I going to get 676? Well, as an estimate, if I rounded this off to 6, then I'm going to get, what am I going to get? I'm going to get 30, and I'm going to get 150. So it's going to be close to 150. So if I put an extra quarter on there, 25 quarters is what, 6 point something? 6.25 again? Yeah, so it's going to be 56.25. That's not going to be, no, it's not going to be close enough to the 676 that we need. So the answer to that one is no, it is not a geometric sequence. Alright, so it's all about what is looking for a common ratio. So common ratio is just a fancy way, but they will ask you for it, so find the common ratio for this sequence, that kind of thing. It's what you multiply by or divide. Let's make that actually look like the word you. What you times or divide by. Alright, so if we look at the next ones, a few examples there. I'm going to continue the next two sequences by finding the common ratio. It's dead easy. I might chuck a few other things in there as well. So the common ratio, we'll just shorthand that to CR. That's been multiplied by 5, multiplied by 5, multiplied by 5. So the common ratio is 5. And then the next two terms, so 1, 2, 3, 4, so the fifth term, what's also called U5 or T5, doesn't really matter, they're kind of interchangeable. You will sometimes see U's written in exams, certainly if you're considering going on to A level. Doesn't matter what you use, U or T. Anyway, so I want to do, I've lost myself now, 250 times the common ratio, so times 5. So T, U5 fifth term, whatever you're calling it, is 1,250. And then the sixth term, or U6 or T6, is going to be 100 or 1,250, that is 620. What about 625? Yes, it is 625 because in my head I was doing 125 times 5. But it's going to be 6,250 because I've got an extra 0. It's fairly easy, isn't it? It's just knowing your times tables in that one. Next one. So this one, the common ratio is to divide by 2. So you are halving it. So I'm going to stick with T, I think. So T5 is going to be half of that, which is 3. And T6 is going to be half again, which is 1.5. Next. Not a particularly nice one. So you are multiplying by, what's that? That's going to be 60. 50s into 60 go 4 times, so it's going to be 40. So you're multiplying by negative 40, because it's oscillating between positive and negative. So it's multiplying by negative. So T5 is going to be, what's 96 times 4? 9600 and brain 92. 400. What am I on about? Oh, good Lord. I think it's the Easter break. It's just done me in. I've lost my complete train of thought now. What was I doing? Oh yeah, 96 times 4. 96 times 4. 6 times 4 is 24. 4 times 9 is 36, 38. 384. And then 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Which you can write in standard form if you like. Kind of depends what the question asks for you. And then T6 would be that times 4. So 4 times 4 is 16. 4 times 8 is 32. Add that one's 33. 4 times 3 is 12. Add that's 15. 1, 2, 3, 4, 5 zeros from the one above, and an extra 0 from the 40 we were multiplying by. Done. Yeah, if you got a calculator you could use it, but there's no reason why that couldn't come up on a non-calculator exam. Right, next one. Looks like it is a division, and it's a division by 4. So your common ratio is quarter. You are quartering your answer each time. So T5 quarter of 20 is 5, and T6 a quarter of that. You could either write as 5 over 4, you could write as 1 1/4, you could write as, I'm going to run out of space, 1.25. Again, if it's in an exam, read the question. If it specifies what it wants it as, do it. If it doesn't, then any of those would be acceptable. And then the last one, we are going from a half to a quarter, so we are halving it each time. And T5 is going to be half of a 16th, which is a 32th. And T6 is going to be half of that, it's 1 over 64. Alright, so Geometric sequences are reasonably simple. The common ratio is usually the second term divided by the first term, or any two sequential terms multiplied by each other, and it's decided to turn around. So it doesn't have to be the first two. It could be any two that are next to each other. You'll get the common ratio from any one of them. All done. Bye.